Am I audible clearly?
Yes, sir. Yes, sir.
Yeah, like today our main purpose of this webinar is to just give idea of some glimpses of the new codes, that ground improvement and ground stabilization, or sometimes we call it as a soil improvement also. So today, as early also, like we have launched this courses of course content specifically related to this. What are the things we are going to cover? But briefly, we will discuss about the indeed the topics what we are going to discuss through in this course, and this specifically this ground improvement, why it is the need of understanding and studying this topic very carefully. My screen is visible to everyone.
Yes, sir. Yes, sir.
Yeah, like this ground improvement is a very vast topic, and it has day-to-day applications to different fields of geotechnical engineering, structural engineering, as well as bridge engineering, and many other applications, especially for the underground structures also. So in general, we understood from the name itself that it's a ground or soil modifications, and there are many techniques, many methodologies are available. But how to choose this ground improvement, this is very important from practical aspect also, as well as in the when somebody is doing some academic exercise also. Like proposing some ground improvement methodology is not so easy, because based on the soil, based on the available structure, available foundation condition, and also economic aspects, we need to take care. So why we should attend, why someone should attend this code? So because there are some few guidelines about the choosing this ground improvement methodology based on the soil particles. Like you can see that based on the soil particle sizes and percentage finer, especially when everybody knows that less than 0.002 micron is considered to be the clay particles, and more than that 0.075 is considered to be the granular or sands, and more than 4.75 is gravelly particles. And also there is another section about the rock also. So how to choose the ground improvement methodologies? There are many methodologies, like very basic methodology like compaction, dynamic compaction, vibratory probes, using some grouts, jet grouting, vibro replacement, and this use of the stone columns, use of the compaction piles, micro piles, use of the some chemical stabilizers. But there are many developments, recent developments also, and there are new methodologies are coming up every day. Almost like there are new methodologies, you will find out there are different case histories. But there is no such kind of one consolidated things you will get where you will be able to choose the ground improvement. In most of the books, you will find out the different methodologies have been described, different methodologies, pros and cons, and some examples, mathematical examples, as well as design examples. But how we will decide in the suppose you are practicing engineer, or suppose you are doing some design, you have to propose some ground improvement methodology. How do you decide this, what should be the technology, or what will be the techniques and most economical techniques in this case? So first of all, like what are the different ground improvement measures we will discuss in the course content. I will discuss again the course content, what are going to be covered in the course content, and in detail things. That why ground improvement required for the different projects. The different projects, it's very easy to say that we have to modify the soil, we have to change the soil properties. Suppose you have to improve the soil shear strength, soil bearing capacity. Sometimes we need to provide more cohesion. Sometimes we need to provide some granular characteristics in the fields. like suppose for example embankment, for example in the retaining wall, for reinforced earth wall, but there is no consolidated things related to that, how we will decide why it is required. An economical decision behind choosing ground improvement measures. We will cover several classical case studies. You will find out, like in lot of books, will show that example of Leaning Tower of Pisa. Pisa is one of the one of the classical example of the ground improvement methodology. But there are many other relevant case studies related to each and every applications, especially from Indian scenario. Due to the vast geological and geotechnical conditions, site conditions, choosing ground improvements in the different part of the Indias are very challenging. And we will discuss several practical problems with the design sheets and how to decide the ground improvement measures, and thorough knowledge about the different ground improvement measures. So after attending this course, you will be able to decide about the ground improvement measures. Suppose you are a designer, you know how to design. Suppose you know how to design deep foundation, shallow foundation, but you need to propose some ground improvement methodology, and quickly you can decide at the site, just knowing the soil properties, that okay, this is the soil characteristics, this is the soil properties, we have to propose the such kind of ground improvement. These are the options, and based on the economic conditions, based on the available other things, we can decide the ground improvement measures. And also there will be many other economic solutions that will also come up in your mind after attending this course, which are not usual or not conventional. So complete guidelines about the ground improvement measures and different industrial applications of ground improvement with design and construction details will be covered in this course. As I told, that different classical examples will be covered. One such examples, we will start with that example in the very first lecture of this course, that Leaning Tower of Pisa, that how the ground improvement controls, because due to the poor foundation and due to the consolidation of the foundation soil, the tower was tilting. But due to that, to become make it more tourist attraction, the tilted towers, how to make that tilt, how to balance that tilt, that the ground improvement measures, ground improvement techniques come into picture, and method of soil extraction, foundation improvement, and soil instability also taken care in this classical case. One of the classical case in Indian point of view is the Kandla port building and ground improvement. I'm not going to the deep discussion in this session. We will when we will start the lecture, we will be able to see the detailed discussion about this Kandla port building, that after the Bhuj earthquake in 2001, how this building was become one of the classical case of ground improvement. And of course, ground improvement has very interdisciplinary dependent things, like it has different things related to the liquefaction. We need to know the different details about the liquefaction induced ground improvement. We need to know different underground foundation soil related ground improvement, poor foundation soils. Wherever it will be, you will find some poor foundation soils. How we will decide about the ground improvement measures. Like why ground improvement? Like you can understand from the name itself that there it must be like the ground condition is not satisfiable to the provisions, or available condition is not sufficient to make some construction of foundation or other structural elements or other retaining structures. It may be, or it may be other geotechnical structures. So we need to provide make it suitable for the construction. We need to provide the ground improvement measures, like embankment construction. We need to check the foundation soil. To construct some retaining wall or other geotechnical retaining structures, we need to check with the ground improvement measures. But how to decide the ground improvement things, and what are the machineries, what will be the design parameters? It's just not a simple mathematically we will propose something, spacing or length of the reinforcement, it will happen. There are some other criteria also we will cover in this course. So major purposes from the name and from the details what we have discussed just now, you can see that the weak bearing capacity, to reduce the settlement, slope stability, drainage improvement, liquefaction potential, seepage reduction. These are very few only. to be named that major purposes of the ground improvement. And regarding the problematic soil also, you can see that the different problematic soils are, it's mostly collapsible soils, it may be some liquefiable soils. How to decide the soils are liquefiable, at what depth, because depth of this ground improvement is also one of the important thing, how to decide the depth of the ground improvement measures. And also the landfill, sanitary landfills, organic soil or PT soil, marshy and soft soils, expansive and shrinkage soils, foundation on dumps, and sandy and gravelly deposits. So these are different problematic soils. There are many others, like soft clay is one of the important soil mostly occurred during the embankment construction, especially for highway and railway embankments, for the road construction also. For poor backfill also one of the important conditions that we are most of the practical geotechnical engineers are facing related to this unavailability of the soil. So ground improvements you can relate these ground improvement topics to everywhere during the construction phase, because ideal soil as per the code or as per the classical soil mechanics are very not very much well available nowadays, because of the lot of construction already happened, because of the space constraint, because of the lot of like compactions, like we are deploying soil, we are disturbing the soil. It's very difficult to get the proper, stronger or kind of suitable soil conditions. So ground improvement is very kind of basic things nowadays in practicing engineering. So one of the example you can see the use of the ground improvement, need of the ground improvement, basically the presence of the swelling and expansive soil in the almost 1/3 of the Indian soil conditions are constituted with the swelling or expansive soil, which we sometimes terms as the black cotton soil, especially western part of the Indians, and there is like huge occurrence of this kind of pavement cracks due to the presence of the expansive soil below the embankment. Very common approach is to replace the soil, but sometimes not always it is feasible or kind of economically feasible to just replace the soil, the expansive soils, because of the swelling and the shrinkage characteristic, and there are other different critical parameters of this type of soils. It's very difficult to decide that how we will decide about the ground improvement measures. Another important aspect, as I mentioned, about the slope stability, because of the slope instability or the slope erosion are very common nowadays in all types of embankment. So slope stability factor, like soil nailing, is one of the important applications of the slope stability. But we will discuss through different case studies, not a single case study. There will be different case studies. For example, soil nailing in the normal soil conditions, embankment conditions, soil nailing in the deep excavation, soil nailing in the rock. So these are the different things we are going to cover during the soil nailing. It will not just be soil nailing, design of the nails, or like length of the spacing of the nails. There will be different conditions, how we will discuss about the different parameters affecting soil nailing, how to decide about the soil nailing will be long-term performance, short-term performance, as well as the durability of these nails, and the different nailing approach, especially for the deep excavation. For example, some deep excavation, we will show some dedicated freight corridor projects, like dedicated freight project, DFCC projects, that the deep cut excavation of the use of the soil nailing as a ground improvement. Another aspect, of course, these are very common approach, use of the geosynthetics, or sometimes we call the use of the alternative materials to the soil, because soil is kind of, we need to think about the soil replacement nowadays, and use of the geosynthetics, use of the geopolymers, use of the enzyme. These are kind of different alternative materials. We are going to discuss about all these things critically. Each and every lecture will be covered on these things, that geosynthetic applications, like kind of use of the geocell, use of the geogrid. So our ultimate objective is to reduce the soils, reduce the thickness of the embankment or thickness of the pavement, or sometimes strengthening the pavement, providing other reinforcements. So geopolymer will be interesting to know. Generally, there will be available many scattered away research papers and some few books, but very difficult to understand how to apply in the field. That, for example, geopolymer, biopolymer. So all these applications will be covered in these lectures, in this course. These are very common, very old concept, that vibro stone columns and vibro displacement piles. So we are going to we'll discuss that vibro stone columns and vibro displacement piles, its applications and its different scenario, how you will decide about the different factors. There will be different companies. We will show the company to company case studies also, that how they decide, how different companies are providing solutions in the real life, and how they decide about the solution, the decision making process. Prefabricated vertical drains, or sometimes called sand drains, and these are also very common ground improvement measures. But nowadays different materials are coming to replace this sand drains, like a kind of jute textile materials as a drains. So this drains design is very common, you will find out in any books, but this application construction detail of these drains we will show with the quality protocols, that how these drains are designed with the proper construction design, the construction methodology of providing prefabricated drain. So after attending this course, you will get complete white paper of application of PVD. Suppose you need to any times after this course, after attending this lecture, you will anywhere you can apply this PVD, wherever you have to apply any kind of things. Like, of course, like you have to decide based on different critical factors, but you can decide, you have the blueprint of application of the PVDs. So one of this kind of approaches, like a decision of the ground improvement measures. So one of the approaches was I already shown that used based on the fine fraction, based on the soil particle size, based on the soil types. Similarly, based on the soil depth, also we need to decide about the ground improvement measures, that how much depth, say for example below 40 feet depth, we can provide the weak drain, we can provide the soil mixed column, sometimes we call it SMC, we cannot provide the roller compaction below 4 feet depth, we cannot provide the soil replacement below 40 feet depth. So this kind of decision making process we will discuss through different charts, and different blueprints will be shared in this course. This is kind of one of the new methodology, but old materials, but very common for the that kind of offshore or kind of jetty, or kind of the structures which are kind of to be submerged conditions, the wooden piles as a ground improvement. These are kind of case histories we are going to discuss, that how these wooden piles are provided, and how can we improve its performance, how can we improve its performance of this wooden pile as a temporary shoring structure, or temporary ground improvement, or temporary embankment improvements. We will show through different case studies. Say for example, one case study, I'm just giving some example, like one case study we are going to discuss on the marine clays of the different part of the India. Is also marine clays are very much available. The marine clays ground improvements will be definitely going to be different from normal these soil conditions. So all those factors are we are going to keeping in the mind. We have developed this course. And new methodologies, as we are going to discuss sometime, that microbiology geotechnology or ground improvement, that microbiomes, that these things are also can be very much effective and very much efficient in improving ground, but lot of trials and experimental things, so we need to decide before going on to with this type of ground improvement measures. We are going to discuss that all the pros and cons and all the detailed procedures of this type of methodologies. So ground improvement against liquefaction, as from the very first case studies we have just shown that regarding Kandala Airport, Kandala Port Tower, that that ground improvement against the liquefaction. What is the most liquefiable soil falls? Like these are we are going to discuss in this course. The special topics like liquefaction related to ground improvement, we will discuss with the different case studies. So special other topics which we are going to cover, like the special strategies for the black cotton soils. Like we know everywhere it is applicable that lime plus fly ash, lime plus bottom ash. But there are some special strategies of the ground improvement for the black cotton soils. Trench stabilization methodology, we will discuss with some very interesting case studies on the trench or on the related to the sheet pile wall, related to the like shoulder piles, how these shoulder piles or sheet piles can be effective in stabilizing trench. Like these are also comes under ground improvement methodology. Electrokinetic stabilization, these are very common nowadays in very abroad countries, foreign countries, they are adopting these methodologies. So we are going to discuss about this electrokinetic stabilization. Bacterial stabilization also, it's well established that bacteria will provide, will strengthen, will improve the soil properties, but how to adopt this bacterial stabilization, we'll discuss with the case studies. Soil stabilization using waste plastic, we're going to discuss. Dynamic surcharging methods and many other methods discussed in the course content itself, we are going to discuss in this course. So who can attend this course? Any BTech graduates, academic practitioners can attend. Master degree students can attend to improve their ground improvement knowledges, because ground improvement courses are very common in master degree, not in BTech. Practicing field engineers can attend this course. Bridge engineer, because we are going to discuss many more topics on the bridge construction related ground improvement. Structural engineers, because the liquefactions and all the details are coming. Of course, structural engineers will find more interest. Like earthquake engineering will also come. So they all can attend these courses. So as we discussed about the course content, like very fast course topic was the giving details about the new technologies, because there are many more technologies are coming up in the current industries are adopting, and this all the new technologies you should be aware that what are the new technologies. Sometimes somebody will take some name and you should not be blank, and you should not just go to Google that what is the new technologies, and that soil needs to be improved. These are very basic things, as in the course content already covered, that in situ ground improvements, design methodologies of all the technologies, in situ densification of the soils, grouting in soils, reinforcement of soils, stone columns, preloading, and specifically the stabilization method, the whole stabilization factors we are going to discuss, and that application, special application for the pavement construction, application on the bridge engineering, we are going to discuss in this course. So these are the brief introduction, brief detail about the course content and what are going to be come up in this course. If you can have any doubts or any queries, you can ask, and if you can add some topics, you can add in this course. Specifically, this course is for practicing engineers and also for BTech and masters people also, and who can take some topics on ground improvement as this his or her research topic also. They can take this course as it will be very insightful course. Any questions and any queries from the audience? I'll be happy to answer.
Hello, sir.
Yes, who is this?
Yeah, Sujan.
Yeah, please tell me, Sujan. Like,
yes, sir. Actually, this presentation was awesome. So,
thank you.
But can I ask one question? Because after seeing all the slides, so or I have seen different soil stabilization techniques. So how can we know that using this method, how much we can improve the soil bearing capacity? So
Yes, this is
yeah,
important question because you want to know the quantification of the improvement.
yeah,
That will definitely be covered because in this was the introductory just insight about the content, course content presentation. Of course, when we are going to discuss about the different methodologies, we will going to share the different improvement factors. There are different way to quantification. Sometimes we show by in terms of the improvement factor or efficiency ratio, or just with stabilization improvement, like for example bearing capacity improvement. So of course, first we'll try to understand the basic mechanism, and of course the detailed process of the design and detailed improvements, like different efficiency factors will come into picture, that how much improvement will occur, short term, long term, different factors. So it is not only short term, like like for example, many times strength will improve for initial strength, but after some strength will show decreasing rate. So that type of detailed insight will be covered in this course for each and every methodologies.
okay.
I will
Thank you.
share the template once we will have the final list of people who are attending, that how we are approaching all the methodologies. There will be some template that okay, like this is the methodology, so we will have the discussion about this way, like same way we can replot all the methodologies in the same page.
Model change करला.
Okay, sir.
Is it insightful for you?
Yes, sir. Hello, sir. And during course, can you show one soil, I mean a geotechnical report, so I can able to see how geotechnical report look like.
Yes, definitely. I will share some technical reports and technical details, like how this practically that ground improvement measures happen, starting from the soil investigation report, how we will analyze the soil properties, and from that we will decide about the ground improvement measures, and of course the construction applications, final applications, final applied case histories.
Okay. Thank you,
This
sir.
course you will be able to see lot of case histories, lot of real life, not only single applications, but not different applications. It will be for the tunnel, it will be for the retaining wall, it will be for the embankment, for foundation, for all sort of geotechnical structures, geotechnical parameters will be covered in this course.
Okay, thank you, sir.
Okay.
Hello.
Yes.
Sir, this is Prashant here.
Yeah, please tell me.
Hello. Yeah, sir.
Yeah, I am
Actually, I'm in
audible to you.
practice. I'm designing ground anchors. Yeah. I'm in practice. I'm doing designs like a cable anchor for Himalayas and
Okay.
cable anchors for Indian metros. So yeah, I hope I decided to attend this your 20 plus hours webinar or anything. So my kind request, can you arrange one booklet or handbook which contain a complete methodology what you are going to uh, explain in this session? A methodology like, for example, if you're telling sand drains, sand columns, anything, there's some field procedures like can you arrange a booklet like?
Yes. There, I have developed some template actually. Like the template will be kind of generalized template. You can use it for other
As per
methodologies
standards?
also. Yes.
Is that template as per standards?
It is not standard because there is no specific standards of generalize all ground improvement methods. You will find out in some particular code. Like you have to consider different factors also. Like you say, for example,
Okay.
suppose we are proposing stone columns. There is some guidelines about stone columns, but you will not find out the comparative, like how they are arrived with the stone columns. Other parameters, if we give the sand grains there, what will be the effect, or what will be the other factors. So those things, comparative things are major objective, like to give the comparison about the ground improvement, because nowadays ground improvement is required for everyone. Like it's very important to understand these ground improvement techniques. I will definitely share those templates and those details, blueprint or kind of white paper, so that you can use for any kind of construction you will, whenever you face related to, you have to propose some ground improvement, just you have to refer to this blueprint.
Okay, thank you.
Thank you. Any other questions? Like I will happy to answer related to the ground improvement. And these course contents have been shared already. I can just have that, just go through this course content again. Yeah, these are the things in detail. Like these are very easy to just name one single topic, but it's a different topics are there inside topics. This is a basic course content. It will be 20 hours lecture, like 20 plus hours. We'll cover each and every topics and different. For example, I missed in the presentation about the shredded tire in ground improvement, use of the river pebbles in aggregate constructions. Steel slag is a soil improvement, because this soil stabilization, soil improvement, soil modification, all the names have different attributes, different topics are involved. You cannot, like, for example, we know that lime stabilization, improving soil properties or changing soil properties, like, through stabilization is different. Replacement, soil replacement is also one of the factors. Many times in the things we just skip the replacement part, soil replacement part. For example, this I mentioned already, that all this like reinforcement in the soil and this grouting, in situ densifications, fibrofotation, fibropiles, and there are different new methodologies are also coming. We should know that different new methodology. That is the major purpose of this course, that we should know the different things related to this ground improvement and ground engineering. Please share any other questions you have. Otherwise, just we'll launch this course. We'll start the lectures from next week positively. Most likely next week we will start, and we can discuss in more detail about this course. I hope all of you will join and enjoy this course. And I'm requesting all of you to join and enjoy. This will be not only just case histories, it will be helpful for any, because ground improvements are very common nowadays to interview questions in any competitive exams also. You will find out a lot of questions from ground improvements, especially any companies interviews, like you will find like 2-3 questions from ground improvement. And it's very common to understand. It's very important to understand all the things, and it will start from the very basic, so that each and everybody will understand. So by this, I am just concluding today's sessions. Anything you can share? I have shared my number and mail ID also, and also this. So Venki will also will be in touch with all of you. You can ask any other queries to Venkatesh. Thank you everybody for joining. Just I'm concluding this session. Thanks a lot.
Thank you.